Chapter 15, Calculations for Simple Dilutions, Mixtures, and Compounding. We will go through these terms throughout the chapter. Let's get past the pretest. If you feel comfortable, go right ahead and start that. And if you are not comfortable, then hopefully you will be after you go through the chapter. So this chapter covers simple dilutions, mixtures, and basic compounding calculations. Dilution may be necessary to compound a lesser strength ordered by a physician. Stock medications may be ordered from manufacturers in concentrated strengths for storage and economic reasons, and then later diluted with a specific volume or weight of diluent. By using stock solutions that are pure and stronger forms of a drug, larger amounts of medication may be prepared from small quantities. The solute and the solvent may be in solid form as well as liquid. A solid diluent is frequently referred to as a base. The pharmacy staff is responsible for diluting to fill prescriptions and medication orders. A solution is made of a solute, which is the drug dissolved, and a solvent or diluent. Various methods may be used to determine the amount of concentrated medication and diluent needed to compound an ordered strength. Simple dilution is used when one product concentration is combined with a diluent that has zero concentration of active ingredient, thus making a more concentrated product less concentrated. Alligation alternate is a mathematical calculation that determines the necessary amount of two different concentrations required to compound a concentration in between the two. Alligation medial can be used to calculate the concentration of a mixture of two or more different concentrations of medications. The following procedures will make these calculations easier. Convert all strengths to percents before performing calculations. Convert all amounts to metric measurements before performing calculations. Compound is considered to be preparing medications according to prescription orders for medications that are not commercially available in the desired strength or dosage forms. Compounding medications in specially ordered doses has become very popular, giving rise to compounding pharmacies. Special populations, such as geriatric or pediatric patients, often require different medication strengths than those found in stock medications from the manufacturer. Individualized hormone replacement therapy, as well as other medication, require specialty compounding. Specific requirements governing the process of non-sterile compounding are found in USP Chapter 795, and you can earn a special certification in compounding. All compounding calculations should be performed using the metric system. With a simple dilution, the amount of active ingredient or solute remains the same and the solvent amount is increased, thus reducing the strength of the stock solution. Simple dilution is the process of making a more concentrated product less concentrated by adding a diluent with no active ingredient. Common diluents with no active ingredient include sterile water for liquid solutions and petroleum for solid solutions. Various cream bases are also available. All right, so we have the equation for diluting stock liquids. Volume units must be the same and strength units must be the same. SV times SS equals DV times DS, whereas SV is the stock volume, SS is the stock strength, DV is the desired volume, and DS is the desired strength. Then we have an equation for diluting stock solids. Pretty much the same as this one up here, except for we have SW times SS equals DW times DS, where SW is the stock weight, SS is the stock strength, DW is the desired weight, and DS is the desired strength. A solute is the substance being dissolved, the stock strength that is being diluted. Solvent is a substance doing the dissolving, a diluent or base with 0% active ingredient. Then we have this formula. Solvent volume is equal to dV minus SV, and solvent weight is dW minus SW. Follow these steps to solve simple dilution problems. Identify the three known variables and use a question mark to identify the unknown. Make sure that the units of volume and weight are the same and the units of strength are the same. Perform all calculations in the metric system. And it's easiest to work with percentage strength, so convert all strengths to percentages. write the equation, fill in the variables, and solve for the unknown. So let's just get right ahead and start. All right, so example 15.1, a physician orders 250 ml of a 15% solution to be prepared from a stock solution of 80%. How many milliliters of stock solution in solvent are needed? So we're going to do our SV times SS equals DV times DS, where SV is stock volume, SS stock strength, DV desired volume, DS desired strength. And then on the side of my paper, I'm going to just write out those variables again so I can easily identify them and then plug them into the formula. All right, so our stock strength is laid out here for us there. So that's 80. And our desired is going to be what the doctor orders. So desired volume is going to be 250 ml. Desired strength is going to be 15%. Notice how I don't have any of the percents or the units on here for right now, and that's totally fine. I think that makes it a little bit more confusing when you add all that in there. And then SV is going to be our unknown. We're always going to have one of these unknown. So I'm just going to rewrite it. I rewrote it now with all of my numbers plugged in. The first thing I want to do is take care of the side where I have the two numbers to multiply. So 250 times 15, which is going to give me 3,750. I'm just going to rewrite this all again. And now I want to get SV alone because that's what I'm solving for. So this is basically just the same type of problem like we do our proportions, but just kind of laid out a little differently, but the process is the same. So we want SV alone, so I need to divide both sides by 80. Because this takes care of that. On this side, it leaves me with just only SV. And then on the other side, I just need to do 3,750 divided by 80, which is going to give me 40. Six 0.89, 88 ml. And then we want to find out how many milliliters of solvent are needed. So for that, we're going to do DV minus SV. So our DV is the 250 ml. And our SV is that 46.88 ml. So we'll just do 250 minus 46.88. And that gives us 203.12 ml. All right, example 15.2, an order is received for 10 grams of petroleum to be combined with 25 grams of 0.2% hydrocortisone ointment. This example deals with weight in grams, and the unknown value is the desired strength. So this is the same as our previous problem. Excuse me. Except for the units are different, but the math is going to be exactly the same. So over on my paper on the side, I'm going to just write out the variables so it's easier to plug in. And it's already told us that our desired strength is going to be our unknown. So I'll put the question mark there. Now our desired weight is going to be the 10 grams the doctor ordered, plus they want us to combine it with 25 grams of ointment. So 10 grams plus 25 grams is going to give us 35 grams. So that's going to be my desired weight. My stock weight is the 25 grams that I have already. And my stock strength is going to be my 0.2%. All right, so I'm just going to plug this in. 0.2 times 25 is equal to DS times 35. Now, this is the opposite side of the previous problem, but it's still the same. First, we want to take care of the multiplication. So we're going to do 0.2 times 25, which is 5. So now I'm going to just rewrite 5 equals DS times 35. I want to get DS alone, so I need to get rid of this 35. So if I divide here, crosses out and I just have DS, and then 5 divided by 35, which is going to give me 0.14%. That is my desired strength. Example 15.3, prepare 500 ml of 5% creosol solution from a stock solution of creosol 1 to 10. How many milliliters of stock solution in solvent are needed? All right, so we need to convert the creosol 1 to 10 first to a percent so that we can use in the formula. So we always want to have the same units. Like we can't have 1% one in ratio, if you know what I mean. All right, so this ratio 1 over 10 is really the fraction 1 over 10. So I'm going to go 1 divided by 10, which is going to give me 0.1. And then I'm going to multiply that by 100. Because a percent is always out of 100. And if this is confusing, check out your basic math cheat sheet. So that gives me 10%. All right, so now I can do my stock volume, stock strength, desired volume, desired strength. And how do I know it's volume instead of weight? I'm looking at the milliliters. There's no grams or milligrams in this problem. So milliliters and liters have to do with volume. So what it's asking is how many milliliters of stock solution are needed. So that kind of gives you a little bit of an preview of what you'll need. So prepare 500 ml. So our desired volume, 500 ml. Our desired strength is that 5%. Our stock strength is that 10%. And our stock volume is what we need, which the question pretty much tells you that. So I'm just going to plug in my information. SV times 10 equals 500 times 5. I need to take care of the side with the multiplication first. So 500 times 5 is 2,500. Just going to rewrite everything again. All right, so I want to get SV alone. So I need to get rid of this 10. So if I do it on one side, I have to do it on the other. So I'm getting rid of those 10 divided by 10 crosses off. And all I have is SV. And then I just need to do 2,500 divided by 10. And that tells me that my stock volume is 250 ml. Now I need to do my DV minus SV to find out how much solvent I'm gonna need. So my DV is 500 ml and my SV is 250 ml. 500 minus 250 is 250 ml. So that's that. So the answer to the stock solution is we need 250 ml and the solvent is also 250 ml. So you can see I've written the conversion factor of 1 ounce equals 30 ml on the top of my paper, because that is what I'm going to need to convert that to. I don't need to do any math. It's just simply 30 ml. And I'm going to write out my formula. All right. So what we are preparing that is our desired is 1 ounce. So our desired volume is going to be 30 ml. Our desired strength is going to be that 0.002%. And then in stock, we have a 1% stock solution. We need to know what our stock volume that we're going to use is. All right, so now I'll just plug that in. SV times 1 equals 30 times 0.002. Which is going to give us 0.06. We'll go ahead and write everything else out again. All right, so now we want to get SV alone, so we need to get rid of this 1. So if we do that on this side, we have SV. Now this side, we have to do the same thing, so that would just be 0.06 over 1, which would just simply be 0.06. Now for the next part, so that's how much stock solution we need in ml. For the next part, we need to do our DV minus SV to find the solvent. So our DV is that 30 ml and our SV is 0.06 ml. So 30 minus 0.06 is going to give us 29.94 ml. All right, so we're going to use our SV times SS equals DV times DS. And again, I'm going to write these over here. All right, and now I'll plug in my variables. So we have a order for 15 ml. So that is going to be desired, right? And the doctor has ordered 10 microgram per ml dilution. So that's going to be our desired strength. And because we have 2 strengths in the same, both with micrograms per milliliters, we can just leave them that way. And then our stock medication, it tells us, is 40 micrograms per ml. And our SV is unknown. So now I can just plug this information in. So SV times 40, I'll just leave out the rest of it because it's 40 micrograms per ml, just for easier multiplication, equals 15 times 10. And 15 times 10 is 150. And I'll carry the SV times 40 with me down here. All right. I want to keep or get SV alone, so I need to get rid of this 40. So on this side, I have SV and I need to do 150 divided by 40, which is going to be 3.75 ml, which it looks like the book has rounded that up to 3.8 ml. So just depending on the problem and what it tells you. And then if we were going to find out how much solvent, we would do our DV minus SV is equal to the solvent. So our DV was 15 ml and then minus 3.8 ml. Which is going to give us 11.2 ml of solvent. Alligation is a mathematical method of solving questions involving the mixing of solutions or compounds possessing different percentage strengths. The process is the same whether dealing with weight or volume solutions. Alligation alternate, also known as tic-tac-toe, is a method that is used to calculate the number of parts of two different percentage strengths of medication that can be mixed together to prepare a third strength that is not available. All strengths must be converted to percentages before performing alligation alternate. As mentioned, the final strength of the mixture must lie somewhere between the strength of the component parts. This means that the prepared mixture must be stronger than its weakest component and weaker than its strongest component. And we're going to do the step 1, prepare a graph similar to a box for tic-tac-toe. Step 2, place the strength to be calculated in the center box. Step 3, place the highest percentage concentration in the left upper corner. Step 4, place the lowest percentage concentration in the lower left corner. Step 5, subtract the center square amount from the left upper corner amount and place the answer in the lower right corner to determine the number of parts of the lowest percentage concentration to be used in the mixture. Step 6, subtract the lower left corner amount from the center square amount and place the answer in the upper right corner to reveal the number of parts of the highest percentage concentration to be used in the mixture. Step 7, add the two calculated parts in the far right column to find the total parts of the two ingredients in the compound. Step 8, when a specific quantity is included in the order, the two parts of the mixture are often written as fractions of the whole, and each is multiplied by the total amount needed to calculate the exact amount of each ingredient. So I know that sounds confusing, so let's just jump right into example 15.6. All right, 50.6. We're going to prepare 1,000 ml of 70% water volume solution from a 50% solution and a 95% solution. So this one we're going to do an alligation, and a good indication that you would do an alligation versus the other formulas is if you had 3 percentages in your problem, which you do. So our desired percentage, just rewrite it right here. Our desired percent is going to go in the middle, and then our high percent is going to go over here, and our low percent is going to go down here. So our desired is what the doctor asked us to prepare, which is 70%. And we have 95 as our high percent and 50 as our low. So now what we're going to do is we're going to do 95 minus 70. So you should be able to do that in your head, but in case you don't, 95 minus 70 is 25. So I'm going to place that right here. And then I'm going to do 70 minus 50, which is 20. So now I have my tic-tac-toe board all filled in. So in my next part, I need to create a fraction. So I'm going to put a fraction next to each number. And I'm going to add up 20 plus 25 is 45. So that is going to be my denominator. Then I am just simply going to carry these numbers over. So 20 and then 25. I don't need to simplify. I can leave everything the way it is. And then I'm going to multiply it by the amount we're preparing in milliliters. So 1000 ml. And I am going to do that for each one. All right, so let's get out our calculator. And all we're going to do is do 20 divided by 45 times 1000. That's going to give me 444.4 ml. And then when I do the bottom, I'm going to do 25 divided by 45 times 1000, which is going to give me 555.6 ml. So now, if I were to add these two numbers together, you can check your answer for these, because if you were to add these two numbers together, you will get 1000 ml. So what this is telling us is, so this is our 95 here. So we are going to use 444.4 ml of the 95% solution. And then of the 50% solution, we're going to use 555.6 ml of the 50% solution. Alligation medial is a method of calculation that may be used to determine the total percentage strength when two or more substances with known quantities and strengths are mixed. Step 1, we're going to add the number of milliliters or grams being mixed to obtain the total volume or weight that is being prepared. Step 2, multiply the percentage strength of each component written in decimal form by the total number of grams or milliliters being used in the preparation to obtain the total number of grams or milliliters of active ingredient that component will add to the total products as shown in the following equation. Decimal form of the percentage strength times grams or milliliters used equals grams or milliliters provided by that component. Step 3, add the amounts of active ingredient provided by each component. Step 4, place the total amount of active ingredient over the total amount of milliliters or grams and multiply by 100 to determine the percent strength of the new product. All right, so let's do example 15.7. Example 15.7. What is the final percentage strength of a water volume solution when 300 ml of 95%, 1000 ml of 70%, and 200 ml of 50% solutions are combined? So the first step we're going to do is add the number of milliliters being mixed to obtain the total volume being prepared. So that would be our 300 ml plus 1000 ml plus 200 ml. We add all those up together, we're going to get 1500 ml. Now we need to determine how many grams of medication are in each quantity to be mixed. So how many grams of active ingredient are in 300 ml of 95%? So what we first need to do is take 95% and turn it into a decimal. So how do we do that? Going back to our basic math, we rewrite it as 95 over 100. Those percentages are always out of 100, and then we go 95 divided by 100, which gives us 0.95. We're going to take that 0.95 and multiply that by the 300. which is gonna give us 285 grams. Now we're gonna do that for each other one. So next, the 70%. If we took 70% and turned it into a decimal, 70 over 100, which would give us 0.7 or 0.70. So now we're going to take that 0.7 and multiply that by the 1,000. So if we do that, we're going to get 700. All right, and then next we have the 50%, which again, if we take that and turn that into a decimal, we're doing 50 over 100, and then dividing 50 divided by 100, we're going to get 0.5 or 0.50. And then we're going to take that 0.5 and we're going to multiply it by 200 from the solution. So 200 times 0.5 is going to give me 100 grams. Now I need to add all three of those amounts. So these three. So let's get our calculator. 285 plus 700 plus 100 equals 1,085 grams. So now what we need to do is we need to place the total number of grams. 1,085, another color here. 1,085, and we're going to place that over the total amount in milliliters, which is 1,500 ml. And then we're going to times that by 100. And the formula that I have is just grams over milliliters times 100 for this. And then we're just going to take out our calculator and go 1,085 divided by 1,500 times 1,000. Or sorry, times 100. And we get 72.3 grams. So if we took that 72.3 grams and placed it over 100 ml by definition, remember this is a weight volume solution, so going back to our last chapter, so it would be grams over milliliters. So that would be 72.3% for the final percentage strength. And then if we were going to we could turn this into a ratio as well, like the book example shows. So we would use that on one side of the proportion, the 72.3 grams over 100 ml. And then over here, we would do 1 gram over X. And then we would just do our math like normal for proportions. So you can figure that out in the answers in the book. But that is 15.7. Example 15.8, I'm going to skip over in terms of working it out for an example, but you can see the problem worked out completely through the book. This is just verifying the results of another example. Sometimes physicians will order a particular strength and amount of medication that they want to be dispensed. In these cases, pharmacy personnel need to calculate the formula to use. Once this is done, a compounding pharmacy may maintain a book similar to a recipe book containing frequently prescribed formulations of medications. Calculations to determine formulas can be performed using the following methods. All right, so let's do example 12 or 15.9. Example 15.9, how much hydrocortisone, which is the solute, and how much eucerin, a commercially prepared base solvent, should be combined to prepare the following prescription. Hydrocortisone 2.5% cream, 30 grams. How much hydrocortisone is needed? So we're going to take that percentage and do like we always do and rewrite it as 2.5 over 100. Now this is working with two weights. So two weighted products. We don't have any liquid. So this is going to be by definition gram over gram. Like in chapter 14 when we learned that. Now on the other side, the full amount that we're going to prepare is 30 grams. So I'm going to place that down in the bottom and this is going to be my X. So now I just need to do my cross multiplying. So 100x is equal to 2.5 times 30. So now I am going to first take care of my side with the two numbers to multiply. So 2.5 times 30, which is going to give me 75. I'm going to carry my 100x down. Now I want to get x alone. So I need to get rid of this 100. That crosses off, and then I need to do the same over here. So 75 divided by 100 is 0.75 grams. Now, that is the amount of hydrocortisone needed. Now, the amount of eucerin and go ahead and do the amount, the desired amount, 30 grams. And then I'm going to subtract that 0.7 grams. That's going to be the hydrocortisone. So 30 minus 0.75, which is going to be 29.25 grams. So this problem could be worked one of two ways. You can either do a dilution problem with stock weight, stock strength, desired strength, or you can do proportions. If you look at your book, it will give you either way. I'm going to do the proportion side of things just because I think it's easier. Ultimately, it's kind of the same though. So 2.5% cream. Remember, that's going to be 2.5 grams over 100 grams because we're working with two different weights. And we want to make the final concentration of 200 grams. How many grams do we need? So we're going to go 100x is equal to 2.5 times 200. Let's get our calculator out. 2.5 times 200. Remember, we want to take care of the side with multiplication on it first. Then we have 100x is equal to 500. We want to get x alone, so we need to divide each side by 100 to get rid of it on this side. And then 500 divided by 100 is 5 grams of hydrocortisone. Now we have the part of how many grams of 10% hydrocortisone cream contain 5 grams of hydrocortisone. So then we would do that 10%, we would turn into 10 grams over 100 grams. And then this time our 5 grams is going to be on top and our X grams will be on the bottom. So we'll do 10X is equal to 5 times 100. So 5 times 100 is 500. 10X. So we want to get X alone, so we're going to divide each side by 10. So 500 divided by 10 is 50. Now, how many grams of base cream are needed? And that somehow didn't get on here. This is the same problem. But this is the last part of the example. So we would start with that 200 grams we have, and we would minus our 50 grams, and that would be 150 grams of base. If the compounding formulation is written, the instructions need to be followed exactly to prepare the prescription correctly. The abbreviation QS, meaning quantity required, and QSAD, meaning quantity sufficient to make, are frequently found in compounding formulations. All right, so let's do example 15.12. Example 15.12. We have a mouthwash that contains 1 gram of tetracycline, 60 ml of nystatin suspension, 48 ml of diphenhydramine, 204 or QS to 240 ml of dexamethasone. This needs to be spaced here. And what is the percentage of tetracycline? And the known information is that there's 1 gram of tetracycline in 240 ml. So the question is, how many grams would be in 100 ml? Okay, so the known information is that there's 1 gram of tetracycline in 240 ml. So 1 gram in 240 ml. And we want to know how much is in 100 ml. So we'll do 240x is equal to 1 times 100, which we know is 100. So I'm just going to save that step of having to do that part. Now we want to get x alone, so we need to divide each side by 240. So here we just have x. And then if we do 100 divided by 240, we get 0.416, which they have rounded up to 0.42, which is 0.42% because it's over 100. All right. Now we can do that same exact thing for each product. So now we are going to go to the nystatin. So this was the tetracycline. Now for the nystatin, it was 60 ml out of 240. And we want to know how much is in 100 ml. So 240x is equal to 60 times 100. So 60 times 100 is 6,000. And then we have 240x. So we want to get X alone. So we're going to divide each one by 240. So this crosses out, we have X here. And then 6,000 divided by 240 is going to give me 25 ml, which is the same thing as 25% because we're making it out of 100 ml. All right, then we would do the same thing for the diphenhydramine. So that would be 48 ml out of 240 ml. And we want to make 100 ml. How many ml are we going to put in our 100 ml mixture? So 240x is equal to 48 times 100. So 48 times 100 equals 4,800, and we have 240x. We want to get x alone, so we need to divide both sides by 240. So 4,800 divided by 240 is 20. So that is 20%. Now, what volume of dexamethasone is needed to prepare the desired volume? This cannot be determined exactly because it is not known how much volume of 1 gram of tetracycline will displace. So the answer is QS AD 240 ml for that part. Example 15.13, a dentist sends a prescription for a mouthwash to swish and spit for pain. It has lidocaine, 0.5%, Benadryl, and Maalox. And the SIG is AA applied to the affected area, QS 120 ml. What volume of each medication is needed to prepare this medication? Because there are 3 parts of the formulation and there is to be an equal amount of each used, divide 120 ml by 3 to get 40 ml of each component. So we're making 120 ml and we have 3 ingredients. So we needed to split those. So 120 divided by 3 is 40 ml each. And this is the type of prescription that you will be working with pretty frequently if you work in retail. This is one compound that you will get more often than others. So what would be the percentage of volume strength of each? Each one is 1/3 of the total. So each would be 33.33%. So you could use ratio and proportion to prove this. So you would do 40 ml over 120 ml like they have here. And then on the other side would be X over 100 ml. So this is kind of just like some of the problems we just did. And then we have 120x equals 4,000 ml. And if you do all the steps, you'll get 33.3 ml. So 33.3 ml over 100 ml is 33.3%. A compounding prescription can also be written in parts. So we have example 15.14. Calculate the amounts required to make 2 ounces, which is 60 grams, of the following formula. So we have 1 part of coal tar, 5 parts of zinc oxide, 10 parts of wool fat, and 20 parts of white paraffin. We need to find the total of all the parts. So 1 plus 5 plus 10 plus 20, add those all together, so all of these, and we get 36. Determine how much of each ingredient is needed. So this is just like the other problems where you take every ingredient. So if we are going to the coal tar, we have 1 part, and the total of all of them is 36. So on one side of your proportion, that's what's going to be on there. However many parts of whatever ingredient out of 36 is equal to X over 60 because we're doing 60 grams. So for the zinc or for the coal tar, we have 1.7 grams. So we're going to do that for each one. So 5 parts out of 36 parts is equal to X over 60. So we'll do all those calculations. And if we add all of these parts, 1.7, 8.3, 16.7, and 33.3, we should get 60 grams, which means that our calculations are correct. When an amount of a compounding formulation requires reducing or enlarging to meet a physician's order, the original amounts in the formulation are used to calculate the new formulation by ratio and proportion. All right, so let's do example 15. So we're going to decrease the amount of product. In an example of 15.15, we have a 3% ibuprofen gel. We have 3 grams of ibuprofen and we have a base of 97 grams. So if we were going to prepare 30 grams of ibuprofen, we would do 3 grams out of 100 because if we add these two up, it's 100 grams is equal to X over 30. So then that gives us 100X times 3 times 30, which is 90. And X is equal to 0.9 grams. So if you do your math like we've been doing for all these problems throughout all of this math, you will get that answer. And if you don't understand, just watch some of the previous examples where I worked all that out or reach out. So you're going to do the exact same thing for the next part. So 97 grams over 100 grams is equal to X over 30 grams. Completing your math, you get 100X is equal to 97 times 30, which is 2,910 grams. You'll solve for X and you'll get 29.1 grams of base. Now, example 15.16 is increasing the amount of product. We have a formulation of 3% ibuprofen gel. Again, this time we want to increase it. So we're making 120 grams this time. So we're still going to do 3 out of 100 grams is equal to X out of 120 now. And we'll do 100X is equal to 360 grams by doing 100X times 3 times 120. And if you solve for X, you're going to get 3.6 grams of ibuprofen. And then down here on the base, you are going to get 97 grams over 100 grams from this here is equal to X over 20. You'll get 100X is equal to 97 times 120, which gives you 11,640, which means that if you solve for X, you're going to get 116.4 grams. Example 15.17, the following recipe is for 10 milligrams per ml of drug A. So drug A is 100 milligrams. There's 10 tablets that we need. Distilled water 18 ml, cherry flavoring 3 ml, simple syrup QS, AS 100 ml. So that means at the end, we want to have 100 ml. So we want to prepare 4 ounces. So first change 4 ounces to 120 ml. So remember, we would use the 1 ounce is equal to 30 ml conversion factor to figure that out because compounding calculations are always performed in the metric system. So we're going to set up some ratio and proportions just like we've been doing. So drug A, if we need 10 tabs out of 100 ml is equal to X out of 120 ml, you'll do just exactly like you've been doing. 100X is equal to 10 times 120, which is going to give you 1,200. You solve for X, you'll have 12. So you're going to do the same thing with every ingredient. And the simple syrup is, of course, going to be QS80, 120 ml, because we're going to take all of those products and then bring that final concentration up to 100 ml or 120 ml like they did here for their 100 ml. So we can figure out a precise amount.